So we've got Newton's laws of motion. How many laws of motion does he have?
3.
Right. So what's his first law of motion? You will need to know which one is which. His first law of motion is called the law of inertia. And what does that law say? It's quite wordy, but as long as you give me the right idea, it tells you something about the motion of an object.
Yes, like I just can't remember.
Okay, so the first law, well, we should do a bit of revision. So the first law says that an object continues to move at a constant velocity, which therefore means in a straight line, in the same direction. Otherwise, the velocity would change if it's not a straight line in the same direction. So an object will continue to move at constant velocity in a straight line in the same direction, unless acted upon by an unbalanced external net force. So the first law is quite wordy, but the concept is very simple. If something is already moving in a particular way, it will keep moving in that particular way. If some object is not moving, it will not start moving for no reason.
Okay.
So if an object, basically the whole concept is the concept of inertia. It doesn't want to change.
Mm-hmm.
If it's moving already, it will move. It will keep moving because it's moving already.
Yes.
Right?
Yes.
Now, if it's not moving already, then it won't want to move. And it will, well, stay not moving. Right?
Mm-hmm.
And that's the whole idea. So if something is staying still, something has to push it to get it to move. If something is already moving, something has to stop it, like push it back to stop it. Otherwise, it'll keep moving forever. Right?
Yes.
Now, that's the idea. Do you agree with this law, though?
Yeah.
You do? All right. So let's say we throw a ball, right? So let's say we've got a ball and we roll the ball, or we kick it and it rolls along the ground. Will it stop?
Yeah.
It will. Now, didn't Newton's law say that an object will keep going if there's no force?
But there is a force, like
What's the force that stops the ball?
the force says
If the ball is rolling along the ground, what's the force that stops the ball?
friction.
Okay, good. So it looks like you're kind of clear on these concepts. So there's friction acting against the ball, which will then gradually slow it down and stop it. Very good. All right. So there's your first law. What's Newton's second law? Yeah. It is?
F equal ma.
Right. That's a mathematical version. All right. F equals ma. And that's basically what it says. If you want the word version, it's quite long. But basically, the word version is the acceleration of an object is proportional to the net force acting on the object and inversely proportional to the mass of the object. Does that make sense?
Yes.
So quite clearly, if F is constant, so if we've got a constant force and I've got a heavier object, it's more massive, what happens to acceleration? So if I've got F equals ma, and I'm keeping F constant, if mass goes up, what happens to acceleration?
Decrease.
Goes down.
Yes.
If mass goes down,
Increase.
yeah. And you can probably see that, right? So you're relatively constant strength, right? If you got something light, you can throw it pretty hard. If you got something very heavy, you can't throw it that hard, right? All right. Now, if on the other hand, this time I keep mass constant, so let me use green to represent the constant. If I want A to go up with the same mass, so I've got the same object, how do I make it accelerate faster?
Mass goes down.
Well, mass is constant. I can't change the object here. I'm keeping mass constant.
The force goes up.
Right. You throw it harder, right? You just apply more force to it. If I apply less force, what happens?
Acceleration goes down.
Right. And very similarly, last one, if I have F equals ma, where this time A is constant. So for the same level of acceleration, if I increase the mass, what happens to the force? The force required must
increase.
And if I reduce the force, then to keep F
nice.
decrease the mass. So note that F equals ma. Now this is the formula. Just to be clear, what does F stand for? What does it represent?
Force.
Can we be more specific?
The force.
So it's the net force, or if you like, it is the sum of all forces. So maybe you're not clear on that. We'll get to that as we go along in this topic. But this F actually represents the net force. Okay. Now, what unit is that measured in? What's the unit of force? Starts with N, and that's what the symbol is. The symbol is capital N. So the unit of force is? Newtons. What does M stand for? What does M stand for?
Mass.
Correct. What is the unit?
And?
Kilograms. And the symbol? kg.
Yeah.
A represents?
Acceleration.
Unit?
Meter.
Per second. Oh, well, that's, I'll just write the symbol. Yeah. Meters per second.
Yes.
And that's your second law. Okay.
Yes.
Now, obviously, we'll be doing, this second law is very important. You'll be doing it, using it throughout this topic lots and lots of times for, there have been any questions. So make sure you do understand it, and we'll get lots of practice on this. And then, this topic will obviously be just spending a lesson, probably at most, going through the general ideas. And then the most of the other times will be just doing practice, because it's more about doing the question here for this topic rather than the theory. The theory is pretty basic. And then once you've got F equals MA, you need to work that out. And then this is really the one that you really rely on to do most of the calculations. And then what's your third law? Third law of Newton's law of motion.
Oh, yeah. So for every action is opposite reaction.
That's probably what your textbook might say or what your teacher might tell you, but I don't think that's a very good way to say it at all. So for every force, there is a force of equal magnitude, so same size, but opposite in direction. So for so basically we're saying forces must come in pairs. Every single force must have another force, its partner, if you like, which is exactly the same size, equal magnitude, but opposite in direction.
Okay.
Now, this sort of rule often confuses people, but if you think about it and if you understand what it's saying, it actually really makes a lot of common sense. So think about this, right? Let's give you an example. Let's say that you want to buy something. Let's say you want to buy something, or you want to help your friend out. What's your friend's name?
Jack.
All right, so you've got Andy and Jack. Let's say Jack, for some reason, doesn't have enough money to buy lunch today. All right, so you want to help him out, and because he's your friend, and you give. So let's say Andy gives $10 to Jack. All right.
Okay.
Now, if that happens, this is a true statement, right? Andy gives $10 to Jack, right?
Yes.
From Jack's perspective, what happened? If I rewrite this sentence with Jack, what would I say?
Jack gets $10 from Andy.
Yeah, Jack receives $10 from Andy, right?
Yes.
Now, question: are these amounts the same? Is $10 equal to $10?
Yes.
Can these be different?
No.
No, right? If you give him $10, he got $10 from you. That has to be the same, right?
Yes.
Now, this is give, right?
Yeah.
This is get, right?
Yes.
Are they opposite in direction?
Yes.
Yeah. So if you, Andy, give to Jack, Jack must have got from Andy.
Yeah.
If you give $10, he must get $10. You can't, this can't be any other way, right? You can't change the number.
Yes.
And if this is give, that's get, and that's that. So when you talk about the third law, it's the same idea, all right?
Yes.
So now, let's say you've got box A, object A pushing object B to the right, all right? So I'm saying A pushes B to the right, with, let's say, 200 newtons of force, all right? So what could you say from B's perspective? What would B do to A?
B receive 200 Newton from A.
I suppose, but if you think of this as, you know, give $10. So if you give $10, did you, you know, in terms of the money you had, did you go up by 10 or down by 10?
Down.
And in terms of Jack, what happened?
Up.
So same idea. A pushed B to the right by 200 newtons. So A pushed B to the right.
Mm-hmm.
So B, in this situation, would end up pushing A to the left. So, you know, this is to the right, this is to the left.
Yes.
But it's also 200 newtons. So that is Newton's third law. Now, it might make a little bit more sense to you after we talk more generally about forces, and we'll come back with more examples. But right now, here are just Newton's 3 laws of motion, which we will refer to as we continue to do problems and so forth. So first law of motion, repeat. It's the law called the law of inertia. And it says, an object will continue to move at constant velocity, which means in a straight line in the same direction, unless acted upon by an unbalanced external net force. Unless there's a force acting on it, overall, it will not change. It will do the same thing. If it's moving, it'll stay moving. If it's not moving, it will stay not moving.
Yes.
2. Basically, second law, basically F equals ma. Right?
Yes.
And the third law, for every force, there is a force of equal magnitude and opposite in direction. Every force is paired up with another force, which is equal in magnitude to itself, but opposite in direction.
Yes.
And these are our 3 laws of motion from Newton. Now, the next thing we need to consider in more detail to apply these laws, I mean, because we're talking about forces, is what is a force? And so that's kind of what we need to think about now.
Okay.